Welcome to our first lesson in Unit 5. We're going to be working with polynomials this unit. So this first lesson is going to be focusing more on vocabulary and kind of how do we write polynomials when there's multiple terms, what goes in what order, and how do we navigate around through that. So first couple things are some vocabulary. So a monomial is a number, a variable, or the product of a number and a variable or variables. So think of it as it's a single term, kind of one piece. So it could be a 3. It could be a negative 4x. It could be just a y. It could be 5y squared z. But it's some combination of numbers and variables all in one term, all being multiplied together. The degree of a monomial is the sum of the exponents of all of the variables. So like for this first one, 4x to the 5th has a degree of 5. We take that exponent on the 5. For 3x squared y to the 6th, we add the exponents, we find the sum, so it has a degree of 8. For a constant, so for a non-zero constant, it's going to have a degree of 0. It doesn't have any variables involved in it. It's just a plain old number, just a plain constant, so it's going to have a degree of 0. All right, some more vocabulary for us. A polynomial is a monomial or the sum of monomials. So think of it as one term or many terms. Okay, a lot of the ones we're going to work with are going to have 2 or 3 terms involved in them. Okay, but notice that word sum, it's always the terms are being added. That's how we can tell one from the next. Now we have some certain types of polynomials. So one is a binomial, bi meaning 2, so it's the sum of 2 monomials. So that could look like a variety of different things. So we could have something as simple as x plus y, 2 separate terms. We could have 2x squared plus 7, or we could even have something like 3xy plus x squared y. Okay? So 2 separate terms that aren't like terms. We couldn't combine them together. My guess is you can figure out what a trinomial is, tri meaning 3, so it's the sum of 3 monomials. So this is where they start to get a little bit longer. So we could have something like x cubed minus 10x plus 1, or xy squared plus xy plus y, or negative 5x to the 4th plus y to the 3rd plus 9. So it's just 3 separate terms put together. All right, so now we're going to look at how to describe polynomials. So the degree of a polynomial is the greatest degree of any term, so of any one piece. And remember from up above, when we find the degree of a particular term, a particular monomial, we're just adding the exponents of the variables. Remember, we don't add any exponents of the constants or coefficients. So here, I have an exponent of 5, an exponent of 2, and an exponent of 1. The greatest is 5, so this one has a degree of 5. Here I've got 2 and a 1, so that gives me a degree of 3. Here I have a 3 and a 2, that gives me a degree of 5. And a 5 and a 1 gives me a degree of 6. So this polynomial has a degree of 6. Kind of what's the highest combined power do we have in any of the terms. So next one, I have a 4, an 8, or remember, a plain constant has a degree of 0. So I have a degree of 8. For the bottom one, 4 and 2 gives me 6. 2 and 5 gives me 7. 2 and 2 gives me 4. So my highest degree, my largest sum is 7. So that's the degree of a polynomial. All right, so back of the page for us. So highlight this part for me up top. When writing polynomials in standard form, you're going to put it in descending order with the one with the highest degree. Remember, that's what we just got done finding. We're kind of adding the exponents of all the variables, and we're going to kind of put them in descending order. Remember, Constants are going to go last because they have a degree of 0. So you might want to add that into your notes there. All right, so we want to put these in order, descending. So I have negative x to the third. That's got a degree of 3. Then I have 3x, that has a degree of 1. And then I have 15. Okay? So next one, 6x to the 7th, the biggest exponent. And then we kind of work our way down by the exponent. So x to the 7th, 2x to the 5th, and then y to the 3rd. Okay? Next, we have leading coefficient. And it's kind of self-explanatory. The coefficient is the number that goes along with the variable. And the leading one is just the one in front. So once it's written in proper form, in standard form, we want the coefficient of that first term. So I got to write this one in order. So I'm going to do 3x to the 5th plus 5x squared minus 15. Then I'm going to take the coefficient of the leading term. So that's going to be 3. For my next one, I've got 4x to the 7th plus 5x to the 5th plus y to the 3rd. My largest exponent was 7, so it went first, and its coefficient is 4. So we're just kind of learning that vocabulary of how things go together. All right, so the next one says, determine if each one is a polynomial. If it is, find its degree. Remember, the exponent of the largest, or kind of the sum of the exponents in the largest term, and then decide whether it's a monomial, meaning 1, a binomial 2, or trinomial 3. All right, so for the first one, that one's pretty straightforward. It is a monomial because it only has one term and it has a degree of 0. Because remember, a whole number, a constant, has a degree of 0. For the next one, I have 3 over q squared plus 5. So some of you might be thinking of, oh yeah, this is 3q to the negative 2 plus 5. If you remember our exponents unit from before break. But for polynomials, we can't have negative exponents. We can't have exponents in, or variables in the denominator. So this one is not a polynomial. Okay. Now, next one, my guess is some of us have worked ahead and we're going, oh, that's a trinomial, it's got 3. Well, no, it doesn't, because if you look, 2 of those are like terms. I can combine some of those together. So 7x minus x is 6x plus 5. That makes it a binomial, because it has 2 terms. And we want the exponent, the highest exponent, well, that's just the exponent on x, which is an exponent of 1. So it has a degree of 1. All right, next one. You'll notice that the variables are different, at least the exponents are in each of those, so we can't combine them together. Okay. It's already in the proper order, so we know this one's going to be a trinomial. And then we want the degree of it. Well, this one here has a 2 and a 1, gives me a 3. Here I have a 1 and a 1, that gives me a 2. So the largest sum of exponents is 3. So it has a degree of 3. All right, so take a couple minutes. I want you to try the next couple. I just want you to do the first 4. Try them for yourself. You're going to write it in standard form and identify the leading coefficient. And then hit play again and then see what you agree with my answers. All right, so hopefully you paused and try these for yourself. First, I'm going to rewrite them in descending order. And then I'm going to take the leading coefficient. That's the coefficient of the first term, so this would be a 1. Here I've got negative 7x to the 5th plus 4. Oh, almost had that out of order there. Plus x to the 4th plus 4x to the 3rd plus 1. Okay, it's descending order with my exponents, and my leading coefficient is negative 7. Here I've got 2x to the 8th minus 3x to the 6th minus x to the 5th. So descending order, and I just take the coefficient of that first term. All right, hopefully you're good with these. Negative x to the 8th plus 2x to the 7th. So descending order in our exponents. And I would have a -1 as my leading coefficient. All right, so for the next couple, E and G on the left, these are going to be pretty straightforward for us. So let's go ahead and tackle those. We have 5x to the 5th plus 8x squared minus 15. So I have a leading coefficient of 5. Here I have 6x to the 3rd plus 13x squared minus x minus 5. And that gives me a leading coefficient of 6. Hopefully you're with me so far on those. But now I want you to look at the next one. Remember, as for f, you'll remember that when we put them in order, we want to put them in order by their degree, the sum of the exponents. Well, here I've got a 1 and a 1 gives me a 2. Here I got a 4 and a 1 gives me a 5. And here I've got a 3 and a 2 that gives me a 5. So here's the rule. When you have terms that have the same degree, okay, and we're trying to arrange them in order, we always deal in variables in alphabetical order. So when this happens, you're going to look at which variable is first alphabetically, and you're going to use its exponent to arrange things. So I would add this little note down at the bottom of your notes. When they have the same degree, look at the first variable alphabetically and use its degree to organize terms. And what that means is, if you look at those two middle ones, this one had x to the 4th, this one had x to the 3rd. 4 is greater than 3, so that one's going to be listed first when we rearrange them. So I'm going to have x to the 4th, y to the 1st. Then I'm going to have 4x to the 3rd, y to the 1st. Then I'm going to have my 10xy, and then my minus 7. So that's going to give me a leading coefficient of 1, that coefficient out front. So when they're tying in their degree, we look at the first variable, and we're going to use its exponent to put them in order. So last one here, quick. I've got a degree of 3, I've got a degree of 6, and a degree of 7. So I got negative 6x to the 3rd, y to the 4th, and then plus 2x to the 5th, y to the 1st, plus 4x to the 1st, y to the 2nd, plus 2. And my leading coefficient is going to be -6. Okay? We're going to use some of this vocabulary and some of these degrees of polynomials here in the next couple of days as we start to practice with these bigger numbers.